Boy, that's so stressful and complicated. All right, we're talking more about proportions just because we haven't done enough with proportions. So there's more properties and theorems that have to deal with proportionality. So the first one is divided proportionality. So divided proportionality, let's say we have two line segments, and on these line segments we have points. So we have point L and point M on these line segments. If I have the proportion AL over LB, so that's on one line segment, equals CM over MD, then those two line segments have divided proportionality. So for example, if I said, okay, let this be 2, this be 5, this be 4, this be 10. So what is this telling me? This is telling me 2 over 5 should equal 4 over 10. So if I reduce the right-hand side of that proportion, I do in fact get 2/5. Now, is there another way we could have written this? 5 over 2 is 10 over 4, right? So, I mean, I could get the reciprocal as well, but this is true. So that's divided proportionality. The next type of proportionality, which is in fact a theorem, is the triangle proportionality theorem. So what this states is if I have a line parallel to one side of a triangle, so a line parallel to one side of a triangle, there's my line, it's parallel to one side of a triangle. So TU is parallel to QS. If I have that fact, then it divides the two sides. So I have my two sides. Proportionally. So similar as if those two sides of the triangle were in fact line segments, like the previous example, I have those points again, right? On those two line segments, and they give us that divided proportionality. Make sense? Again, keeping in mind that we can interchange the means, we can look at different forms of the proportions, of the ratios, and we can get reciprocals. So there's not just one way to write these proportions. There are equivalent versions of these proportionalities. So let's look at an example. What they want you to do in this example is find the length of BD. So what is BD? BD is just that little piece there. I'm going to call it X. So let's look at what we have. As in the triangle proportionality theorem, I do in fact see that this is parallel to this. So if that is parallel to the base of the triangle, I know that I am dividing each of those sides of the triangle proportionally. The two sides are proportional. So let's look at what we know and write a proportion. I can see that AB over BD, so AB over this BD, which we are looking for, X, equals what? Equals AC over CE. That is absolutely correct. So the little triangle, oh, I shouldn't have done those. Oh well. AC over CE. I have another color, green. Okay, so let's substitute in the values that we know. AB is 33 over our unknown x that we are solving for equals, what is AC? Over CE, 18. Now at this point you can go ahead and cross multiply, but if you want to simplify and reduce independent fractions to work with smaller numbers, you of course can do that. That would not change your answer, because at the end of the day, at the end of the problem, we have to reduce anyway, any answers. But I'm going to go ahead and cross multiply. So I have 33 times 18 equals that x that I'm solving for times 27. So if I divide each side by 27, what am I going to get for the value of x? 22. Can we get 22? Not bad. Yes, ma'am.
You set it up 33 over 27.
Yes. And what tells us that we can do that? The fact that our geometric means can be interchanged, right? Remember, there's a property that says that. That is absolutely correct. Absolutely correct. So there is not just one way to set up these proportions. Now, let's go ahead and look at this. We are solving for x. In this case, x is the length of this whole thing. So if this whole thing equals x, and this equals 15, what can I say about the missing piece? How would I represent that? Not this little piece plus this unknown equals x. So this plus this should give me x. So this is x minus 15, isn't it? Right? Because 15 plus x minus 15 is just that x. So I just kind of want to get, not that we need that for this problem, but I wanted you to get in the habit of being able to recognize and represent missing pieces of these diagrams, because that will help you on the test. All right, so let's go ahead and set up a proportion. So I'm going to personally, I like to look at the whole thing compared to the smaller part. So that's how I'm going to define my ratio. So if I look at the whole side, well, if I'm looking at whole sides, what is the length of this whole side? 28. So I could say 28 is to what? What's the whole side? Well, this whole side compared to the length of the other whole side. X equals, and now I'm just going to look at these little smaller triangles, the smaller triangle. So that would equal what? 20 over 15. Do you see how I set up that proportion? The one whole side compared to the other whole side equals the one smaller side of that triangle to the other smaller side of that triangle. Again, I would cross multiply, so I'd get 28 times 15 equals 20 times x. So if I multiply on the left-hand side, that'd be 420 equals 20 times x. So what is x? 21. Good. So this whole side is 21, and if I wanted to really know what the length of this is, I could subtract 15 from it, right? And get 6. Good. All right, let's see what x is. Yes, Jackson. What did I just say? Is there another way we could have done this? Yes. Knowing what we know about means, I could interchange these, right? And I could have done 20 over 20, 28 over 20, like comparing one side large to small over x over 15, right? I could have interchanged those.
Oh, the other method I was saying would have been like 20 over 8, or like, so I mean 15 over y.
Well, so you're defining this to be y?
Yes.
Yeah. Yes. Yes. That is yet another way. Absolutely. Okay, let's see what x is in this next example. That's the x that we're looking for. Now, if I know this whole side is 27 and this piece is 15, do I know the length of this little piece here? What is it? 12. Okay. So we can set up a proportion. Again, many different ways. If you want to do it a different way, by all means do it a different way. See if you get the same answer. We should get the same answer no matter what proportion you use if the proportion is set up correctly. So let's take a look at the outside, or let's look at one side, rather. One side of the triangle compared to another side. So if I look at one side of a triangle, I would have maybe 15 over 12 equals, what would the other side of the proportion be? Excellent. And then I'd cross multiply. And what is x? Now, if you set it up a different way, did you get the same thing? Yay! All right, in the next example, let's see what we're looking for. We are looking for x. We know the whole side of that triangle, the hypotenuse of that triangle. It's looking like a right triangle, yeah. Is 20. That's x. For kicks, can you tell me what this piece is? Good. Okay. What if I looked at the whole large triangle compared to the small triangle? So I'm going to set it up as the whole triangle compared to the smaller triangle. So I would say, what is the length of this side? Okay, so that whole thing is 16. So maybe I could do 16 is to what? 20 as, and again, I want to look at the smaller triangle now. I'm sorry? 12 over x. And then I'd cross multiply, and I'd get 16x equals 20 times 12. So 16x equals, again, 240. So x equals 15. So this would be 15, and what would the smaller piece be? Yes. Good. So we have the triangle proportionality theorem. I can take the converse of that. So let's look at what the converse tells us. Oops. Oh my goodness gracious. I'm just having all sorts of issues today. Let's look at the converse. The converse says that if I have a line that divides two sides of a triangle proportionally, so now I'm working backwards, so now I'm beginning with a line that divides two sides proportionally, so then these two segments are proportional. Then it must be parallel to the third side. So instead of starting with the parallel lines and getting the proportional sides of the triangle, I'm starting with the sides of the triangle being divided proportionally and getting the fact that they're parallel. So let's work an example. It is saying that RT is 21. It's saying that TQ is 56. RU is 16. And US It is 48. The question is TU parallel to QS? Let's set up a ratio, shall we? Does anybody want to give me a ratio I can use?
21 over 56.
That's fantastic. That's what we're trying to figure out. So if I wanted to reduce the fraction on the left-hand side, what would I divide the numerator and denominator by? Is there something more? Yeah. Well, I shouldn't write that. Well, let me not write it like that because that's technically not accurate. So what does the left-hand side simplify to? 21 divided by 7 is 3. 8. So the question is there a common factor on the left-hand side that I can divide by to reduce it to an equivalent fraction or the same? So if I divide by 16, I am going to get what? 1 over, oh. So are they parallel? No. Because those aren't equivalent fractions, right? 3/8 does not equal 1/3. 3/8 does not even reduce to 1/3, even cupping your nose. We okay with showing that? All right, let's look at a corollary to that beautiful original triangle proportionality theorem. It's saying if I have 3 parallel lines, here they are, 3 parallel lines, and they intersect 2 transversals. There are my transversals. Then they divide the transversals proportionally. Well, that makes sense. So let's write that out. If I have AF is parallel to what? Which is parallel to CD, then I know that AB over BC must equal what? On the other transversal. Now, could I have written that another way? Absolutely. I could have taken the reciprocal of each of these, and they'd still be equivalent. Yes. Yes. And I could have also done AB over FE equals BC over ED, right? I'm just having all sorts of technology issues today. All right, let's work an example with this diagram. See if we really understand it. We have AB is 25 minus X. AB is 25 minus X. I have that BC is 25. I also have that FE, no, I do have that too, but I have ED equals 4. And I have FE equals 16. Find X. Okay, so I'm going to compare side AC to FD. Tell me the proportion. If I do component-wise, piece to piece. How can I set up a proportion? I love it. Equals. Fantastic. Now, if you want to reduce the right-hand side to work with smaller numbers, what would it reduce to? Yes. And then I would cross multiply, and I'd get 25 minus x equals 25 times 4. You don't have to reduce, but if you want to work with smaller numbers, you can. Then what would I do to solve for x? Okay. Could I have subtracted the x? I mean, added the x? I could. So what is x? What? Negative 75. Is that a valid answer? Can I get x to be negative? Why not? What does x represent? X is this.
I don't get how. I tell.
So x is not the length of this side, bless you. X is the value that I am subtracting from 25 to get the length of that line segment AB. So I mean, you know, you should see a negative and go, oh, is it valid? But then recognize what x represents, because this now becomes 25 minus a negative 75. So what is the length of AB? 100. So what is the length of AC? 125. What are you confused by?
Like did you just flip it?
What?
Like you had negative x at the same time and you had
I divided each side or multiplied each side by negative 1. Does that make sense? So if I multiply this by negative 1, if you want to think of it as multiplication, then I get x on the left and I get negative. Does that make sense? Do you see why it's okay for this to be negative? If x was just a length, then you would say, oh, that's not possible. But it's not a length. It's a value that allows us to calculate that length, which will be very important when you get to algebra 2, because there'll be things called extraneous solutions that you have to throw out because they're not possible. So that's, you know, I like that you're thinking, uh-oh, but recognize that it is okay. Yes.
Does that mean 25 minus x equals 100?
No, 25 minus, yes, 25 minus x equals 100.
Oh.
I'm gonna get rid of that. That's kind of annoying me. But, oh well. All right, what is x in this next one? Find the value of x. Oh, I'm looking for x. Okay, let's compare transversals, shall we? Does anybody want to give me a proportion? (27 over 18 equals x plus 10 over x. I love it. Okay, what are we dividing the left-hand side by to reduce it? Okay, what does that reduce to then? 3 over 2 equals x plus 10 over x. So that gives me 3x equals 2 times x plus 10. So 3x equals 2. I'm distributing. Then I'm combining like terms. And so what does x equal? So this is 20, and this piece here is 30. Good. Excellent. You see that I'm desperately trying to get rid of that horrible little thing. Still not gone. All right, we have two parallel lines. I have that KL is parallel to MN. So we need to Shall we look at the smaller triangle compared to the larger triangle? I'm going to look at the smaller to the larger. Can someone give me the corresponding proportion? I'm looking at the separate sides. Equals. So maybe I can't do that. So maybe I have to look at this compared to this over this compared to this. Well, I'm looking, we can do that, but I'm looking at the smaller compared to the larger. So 9 over 7.5 equals 22.5 over y. So I can solve for y first. So that's going to give me 9y equals 7.5 times 22.5. If I multiply the two numbers on the right, what do I get? Anybody? That. Divide each side by 9, and what is y? You have calculators. What is it? What is this length? Yes, sir. Yes. So I'm looking at that, right? The smaller to the larger. That is correct. So this is 18.75. How am I going to find x? Can somebody give me a ratio? Substitute. Oops. 9y, oh, sorry, 9 over 13.5 equals over x, right? Because isn't this 37.5 minus x? So I have this over this equals this over that. So that's going to give me 9x equals 13.5 times 37.5 minus x. So that gives me 9x equals, if I distribute, I'm going to get 506.25 minus 13.5x. Then I'm going to add and get all my x terms on one side of the equation. So what's on the left-hand side? So what is x? Yes.
So my ratio was 22.5 over 37.5 is equal to 13.5 over x. But I didn't like
Say that again. You did 22.5
over 37.5.
over 37.5. Okay.
Equals 13.5 over x.
Would that have worked?
Yeah, but I didn't feel like the smaller.
That's okay. Again, there's not just one proportion that will allow you to solve for the unknown value. There's multiple ones. Yes, ma'am. Any other questions? Are you sure?
Actually, yeah, when you do 9 over 7.5 equals 13.5 over 18.5.
You did 9.9 over 7.5 equals.
13.5. Oh.
Yeah, that's not a triangle. I love, oh, y'all are so good. Look, the beautiful discussion. I love it. It's not a triangle. Do you see why? Excellent. All right, one last theorem, the triangle angle bisector theorem. Triangle angle bisector theorem. So I have a ray, and it bisects the angle of a triangle. So here's my ray, and it's bisecting this angle. Then it must divide the opposite side into segments whose lengths are proportional to the lengths of the other two sides. And what are the other two sides? These. So let's write that out formally. If I have a ray, what is my ray? That is bisecting the angle, BD. So if BD bisects angle what? Beautiful. Then I know this over this. So AD over DC equals, what is the side of this triangle here? Yes, 27. Well, let's write it in terms of the sides. B, AB. Good. Or we could have written AD over AB equals DC over BC, right? Interchanging our little means. Remember? We could have interchanged these. All right, so I am looking for, yes, Jackson.
Wait, does that say if BD bisects angle AC?
Yes.
Oh,
So they want us to find the length of AD. So I'm just substituting in what I know. Let's write out the proportion. So if I'm looking for X, X over, beautiful. So this is 40 minus X equals what? Fantastic. So then I have 45X equals 27 times 40 minus X. And I'm going to distribute. Yeah, you want to reduce? You prefer to do that first? Yes? Okay. Absolutely. What do we want to divide the right-hand side by? By 3? Well, if you could do 3,
3 over 5.
divide both of them by 9. You can do 3, but you could also do 9. I mean, if we're going to simplify, let's do it. So what is my right-hand side simplified to? Okay. Then I cross multiply. So what is X? 40? No. Sorry, 15. So if this is 15, well, I'll put it up here. Then what is DC? Good.
And you could have done 27 over X equals 45 over 40 minus X also.
27 over, yes. Yes, yes, yes. Try the last two. See if you can get them. Good practice. Try the last two. Did anybody get X for the first example? It is 16. Does anybody need to see that one, or are we okay? Layla, Georgia, we good?
Yes.
Excellent.
Yeah.
But Jackson, you should have a calculator. I got dinkers in the back. Okay, when you get the next one, let me know. If we need to work it out, we can work it out. But if you got it, you got it. Anybody get the second one? What did we get? 5. Do we need to see that one? No? Okay, you have a 7.6 assignment, so you can go ahead and work on that. You got 25 minutes. You could probably make a big dent in it. You will have over the weekend. It's not going to be due till next week. Tuesday, we will be working on the review. If you want to pick up the review packet, it is here. You can start working on it this weekend if you would like, but Tuesday will be a work day on the review packet. Girls, y'all don't have to stay logged on if you don't want to.
Thank you.
You're welcome. Have a good week.